All right, guys. Welcome to engine repair. Excuse me. Ooh, almost screwed that up. So we are going to start the next 4-week course. Thank you everybody who got their HVAC done. This one is a little bit longer than HVAC. There's 8 chapters in your book, but this is probably what most of us are excited about. Engine repair, the nuts and bolts of how this goes together. So in engine performance, which we all took as the second module together, we talked about what it takes to keep an engine running, induction, spark. We talked about the emissions system, all your check engine light stuff. Here we're talking about mechanical things. So this is a shift because there's probably not going to be a check engine light when you have problems with the mechanical aspects of it. For this course, we're going to have 4 weeks. Today we're going to talk about removing an engine. Week 2, we'll talk about everything in the cylinder head. Week 3, we'll talk about everything in the bottom end, the cylinder block. And week 4, we'll do ASC practice. So I've mixed things up a little bit. In your CDX, this time we're doing engine repair right here, number 1. And your access code I sent to you, but if you didn't get it, it's 2DDA38, 2DDA38. Once you get in here, I've gone ahead and put the worksheet for you. So if you'd like a worksheet, there you go. Download, follow along with me. Also, I've decided to change things up a little bit. This week we're going to have a forum, so instead of you calling me on Thursday, which most of you are not doing, in order to receive attendance this week, which is the biggest part of your grade, please remember guys, for those of you who are only doing CDX, if you get 4 days worth of attendance, you don't have to do any quizzes, score 60s on all the tests, and get an 80 on the final, and that's all you have to do. But attendance is the biggest thing, so I need you guys to make sure you're nailing that. So in order to receive attendance this week, we're going to do a forum together. So right here under announcements, week 1 discussion, I expect you to reply. So on mine, because I posted it doesn't say reply, but on yours there'll be a reply button. I want 50 words minimum, and I want an answer by Wednesday night at midnight. So I'm going to check on this Thursday morning. If you've replied, you get attendance. If you have not, then you will not. So pick one of these 3 topics and then write 50 words about it. It's that simple. So either what was your first engine you worked on? What did you do? This could be anything. Your aunt's lawnmower, your uncle's boat, whatever, if you have prior experience. Or what engine do you think sounds the best? And I need specifically which engine. I want you to do a little bit of research. What's the engine code? What's it called? So I like rotary engines. Of course, right now, off the top of my head, I can't think of the body engine code for one. So let's do a Honda engine. So like the K24 that's in all the Accords right now. Or the famous B18 if you're a Chevrolet person. The LS would be a great example. And what vehicle it comes in. What do you like about it? Open-ended question. Or number 3 here, what is it that you don't understand and need specifics about when we talk about this engine? So maybe you've watched these shows on Saturday morning where those hot rod guides build engines and maybe seen them miking some parts, or maybe you've heard balancing and blueprinting or sleeving an engine or stuff like that. So if I don't cover it, or you specifically want some feedback, let me know. I'll be more than happy to reach out to you or come up with some content. So this needs to be done Wednesday night at midnight. Let's begin. Let's begin with a little bit of review. So, what does it take to make a gasoline internal combustion engine run? The 3 things are air, fuel, and spark. You guys should remember that from engine performance. If the question says what 4 things, it's air, fuel, spark, and compression. And so air, fuel, and spark. When we're talking about this engine running, especially in engine performance, we've got a misfire or the engine's not idling correctly or it's got a lean code. We're really concerned with vacuum leaks, exhaust leaks, things like this. In this, from this point of view, engine mechanical, this is where that last one, compression, comes in. So we're going to talk a lot about that. Um, and don't worry, this is one of those modules that is intended to be lots of hands-on. So if we were in class this week, we would be doing stuff on our cars and we would be in the shop. I will not forget these things. As soon as we get back into class, then we will spend weeks of not me lecturing and simply doing hands-on stuff. So don't forget about it. The other thing is, if you haven't already, stop and get some pen and paper so that you can take notes, so that if you have questions, I'm here to help. But if you guys don't put forth a little bit of effort, I can't get you there. So let's review the 4-stroke cycle. And just like I've always drawn it for you, it's amazing that this diagram has it the same way, because this is how everybody does it. The 4 strokes are intake, compression, power, and exhaust. We know that. On the intake stroke, the piston moves down, the intake valve opens, and that creates a vacuum on a naturally aspirated engine. And this vacuum pulls air, and it will have fuel mixed into it before it gets to the intake valve, pulls that into the cylinder. On the compression stroke, we're going to squeeze that air and fuel. Both valves will be closed. Once we reach top dead center, and so my trick question was on which one of these strokes does the spark plug fire, but you guys know now that it fires right here in between the compression and power stroke. Once that spark plug has fired, the air and fuel begin to burn, pushing the piston down. My power stroke, this is the one stroke that we rely on. If we're not getting this, then the engine's not going to run. Piston travels to the bottom. We get all of that energy turned from chemical energy to what is now kinetic energy, and when the piston travels down, that will rotate the crankshaft, which now we have rotational energy that we're going to move through the drivetrain and get to the drive wheels. And finally, I can't pull fresh air and fuel in if it's full of exhaust, so the last stroke is the exhaust stroke. My exhaust valve will open, and the piston moves up because it's being pushed now by the crankshaft and pushes the exhaust out. So, on which one of these strokes is the intake valve open? That's right, the one and only stroke named intake, and the exhaust valve only opens on the exhaust stroke. The ideal air to fuel mixture. Show of hands. What's it called? The stoichiometric value. You need to remember that word. It's going to be on every test you ever hear. And the number. Who knows the number? 14.721. And that's only for gasoline. Diesel's different. If we're talking about E85, that's different. But for gasoline engines. Here we've got a simple breakdown of an engine, just so that we're all on the same page here. I always like to start at the bottom. We've got a crankshaft. It must be a 4-cylinder. This cutaway here, we have 4 cylinders. There's a common line through this crankshaft. There has to be. That's where we bolt it to the cylinder block. And in week 3, when we talk about the bottom end of the engine, we're going to talk about those bearings and everything that is involved, so that when you meet one, you won't be afraid of it. Attached to the crankshaft are connecting rods, and attached to those are my pistons. You'll note that there's no bolts in the piston. It is held by a wrist pin. So it doesn't show, there's no arrow here, but this circle, that circle right there, would be your wrist pin. It's held in by C-clips. You'll note around the pistons are rings, a minimum of 3. The bottom is called an oil scraper, and the top 2 are compression rings. That is, as the names imply, to keep compression above the piston and keep oil below the piston. Rarely do we see oil sprayers or oil jets in these diagrams. We have a V6 in the shop that I would show you, where you can clearly see the oil sprayers. So when the piston travels up, we want to be able to get oil all on the side of the cylinder wall. And so it routinely will spray oil onto the cylinder wall, and as the piston travels down, that oil scraper will scrape it back down into the oil pan. This rotating motion of the crankshaft in the bottom of the oil pan is very likely to touch the oil. So now that we're churning the oil in the bottom of the pan, it's going to aerate and create pressure. This is why we have positive crankcase ventilation, your PCV valve, because the simple act of running an engine with a wet sump oil pan is going to create some positive crankcase pressure. And we don't want that to become extraneous. The gasket at the bottom of this oil pan should never leak. And likewise, on top, it's not shown, but the valve cover gasket should never leak. There's not sitting oil on that. There's not oil sitting on that gasket, but it's because of high crankcase pressure that it will push a small hole. It'll push a small way out to alleviate that pressure, and then oil will follow. So remember, I told you guys in engine performance, if you meet an oil pan gasket or a valve cover gasket that is leaking, it's really probably because of the PCV valve. Go ahead and price one out there rather cheap. Now we move above the pistons and you can see my valves. Very simple drawing with one intake and one exhaust. Valve springs, and they all ride on this one camshaft because this has one camshaft and it is located above the head. The line for the head is not drawn, but that's what this seam here where my mouse is, right here. The head would be the top part, the cylinder block would be the bottom. So because this one is above, it's single overhead. My camshaft is rolling right on top of the keepers for the valves. We see we have a spring. That's what snaps the valve closed when the lobe of the camshaft is not pushing on it. And as the camshaft rotates, these lobes will push the valve down and allow air and fuel in or exhaust out. And this has a terrible carburetor. Pay no attention to that carburetor. The number one most common fault with an engine when we talk about engine repair, when we talk about it's making noise, is going to be leaks. It's going to develop a leak first, and when it runs low on, what are the fluids inside of this engine? Engine oil for lubrication, the lubricating system, and engine coolant for the cooling system. This is your number one fault. It's going to run low on coolant, overheat, and then we have serious problems. It's going to run low on oil and then have serious problems. So the number one thing when you guys get this will be a leak. That will lead to some of my parts wearing prematurely and or worse, we could have some knocking going on. So I'm actually working on an engine that has a connecting rod knock. And life lesson of the week, guys, here we go. So it's a Miata, and I need to get the oil pan off the bottom. So let's look up here. Connecting rod. Connecting rod has a cap on it, and there's a bearing that holds it against the crankshaft. Okay. So all I really need to do is drop the oil pan, and I can access these caps and put new bearings in. So I told the guy, no big deal. It's a Miata. Jack it up. I'll just take the oil pan off. Well, come to find out that it's not that simple because the subframe is in the way. So either the engine has to come out of the top or the subframe has to come out of the bottom. Life lesson of the week: before you tell somebody you're going to work on it, go check the labor time. So I have here Pro Demand pulled up. The vehicle's already in here. I don't know if it says Miata Mechanical. And right here you can see connecting rod bearings. This is the time, the labor time that I should have quoted. 7.2 hours. So when you see 7.2 hours to take an oil pan off, you go, maybe there's more to it. And so I should have done that first. So life lesson for everybody, especially me. Don't do that again. I kind of want to pause here to mention that a lot of the times I really emphasize diagnosing, mainly because we get one shot at it and that's what we get paid for. But every time we talk about something like, oh, the AC compressor has failed, well, can it be rebuilt? Yes, it can. Would it be cheaper to just buy a new one? Yes, it would. What about brake calipers? What about so many components on the vehicle can be rebuilt, but we just don't rebuild them anymore. You hardly aren't even allowed to touch transmissions anymore. My experience at Toyota was if the vehicle was under warranty and had an automatic transmission problem, Toyota didn't want me to take it apart. Toyota would rather send me a brand new one and send that transmission back to the field service engineers because they wanted to go through it with a fine tooth comb. And the other side of it is we have so few of those failing. I said all that to say this. The engine is the last big component that we expect you to be able to take apart. So, if you haven't had a lot of hands on and you haven't done a lot of disassembly, this is going to be where you get your feet wet. You will be doing head gaskets way more often than you will be rebuilding a rear end, for example, or putting new gears in a manual transmission. So the same sort of disassembly, this is going to be where it really matters that you learn sooner than later. And I cannot stress enough how important it is to stay organized. When you disassemble this engine, some of it is going to need to go to the machine shop, and we're going to talk about that at the end of the worksheet. And that means it's going to be away from you for some time. Most machine shops have a 2-day turnaround time, which isn't bad. I mean, I've waited longer. So imagine today's Tuesday, you guys pulled the heads off of whatever you're working on. You send it to the machine shop. They bring it back Friday. In between Tuesday and Friday, you've touched 60 other vehicles or however many other vehicles you've touched. Do you really remember where every one of those bolts go? Do you remember where all the clips went? All these sort of things. So, absolutely, it's important that you stay organized. However, you like to do that, I've seen people lay blue masking tape on a table so they can draw on it with a Sharpie, and they'll just make a line. These are valve cover bolts. These are intake manifold bolts. I like to do the red rag method. I lay a fresh red rag down, and everything that came out of whatever goes on this rag, and then I fold the rag over. Next rag, everything that came out of the next big chunk goes in this rag, flip it over, because those are absolutely reusable. And if you draw on them with a Sharpie, nobody's going to care. So just something to remember. Here, because we're not using a check engine light, you are going to rely on your ears a lot. And a stethoscope is going to be your biggest friend. So if you don't have one, go to Harbor Freight and get a cheap one. You can use a wooden stick, works well. If you're in a pinch, they're just unwieldy and difficult to manage. Most of the time, the engine is going to need to be running to listen to it, right? So if the engine's running and belts are being pulled and pulleys are spinning and things are moving, we don't want to stick something in there that might get caught and rip our arm off or punch us in the face. So a thin stethoscope is very helpful. If you don't have one and you have to do the wooden stick method or a long extension works, when you put it to your head to feel and listen to the vibration, you don't stick it in your ear. Please don't stick it in your ear. What you need to do is take your hand and put it on the side of your head. So go from your ear and go toward your face a little bit, and you have a cheekbone right there. Put the wooden pole or the extension you're using on your bone on your head, because we're listening and we're feeling for vibration, and then that way you don't stab yourself in the ear. A, and then B, that's really what we're looking for, is we need to find whatever this knocking is, and it'll transmit into your ear, your inner ear, better that way. So little tip, don't hurt yourself. This is one of those things where you're going to have to be clever, and you might have to stop what you're doing and walk around and think about it. So don't get in a hurry and start disassembling the engine. You cannot do a proper diagnosis of the engine with it disassembled, because then it won't run. Like, oh, I'd love to take it apart and look inside. Well, what if you look inside and you don't know what you're looking at, A? Or B, you don't know what you're looking for? Or C, you don't find anything wrong? So let's pretend you looked over all the parts and you don't know if anything's actually wrong. What are you going to tell them? So we need to decide what's wrong with it before we tear into it. And once we tear into it, we're going to prove. Does that make sense? So this engine that I have on the Miata that's making noise, which is, it's a different Miata this time. It's not the red one, it's a black one. When I went over there, it's making noise. I've decided it's the connecting rod bearing. I used a stethoscope. I got under the car. I'm going to take the oil pan off and look for proof of a connecting rod bearing having failed. And if I don't find it, I'm going to put the oil pan back and look again, or run it again and listen. So I like to put on this page, on page 2 here, valve timing. When we first did engine repair, I told you that the intake valve is only open on the intake stroke and the exhaust valve is only open on the exhaust stroke. But you've heard of the term valve overlap, and this is when they're both open. And this is a really cool diagram on the left. This shows for one full rotation of the camshaft here, how long some things stay open and how long some things are closed. So if we look here, it overlaps a little bit into the next stroke. And I think that's cool. So just something for you guys to look at. When we're searching for a leak, I need you guys to remember this because number one thing we're doing right now, engine repairs, we're looking for leaks. So when you find proof of a leak, it's going to be at the lowest rearmost portion of the car, where whatever it's touching. So when you are looking for the source of it, so let's say you pulled the skid plate off the bottom of the car, do an oil change, and there's proof of coolant or oil on the bottom. All right, man, it's got a leak. Well, where is it coming from? So you look up and you see coolant dripping off the oil pan. Is coolant leaking from the oil pan? No. And oil probably isn't either. So what you need to do is move to follow that coolant, follow that oil all the way forward and all the way up. And this is what I mean. All the way forward to the front of the vehicle because the wind pushes it back. So wherever you see it, keep moving forward until you don't see it anymore and keep looking up because gravity pulls it down. So if we see coolant on the oil pan, on the cylinder block, we keep going up and we find it also on the water pump. It didn't move up from the cylinder block, it came down from the water pump. So that makes plenty of sense, but it's just one of those easy tips. Remember, tell your children, tell the people who follow in your footsteps, always go forward and up when you're looking for a leak on anything. And when in doubt, get creative. So if we have to duplicate a noise, the best example I can give you is one of these pulleys on the front of the engine is making a noise. Some pulleys make a distinct noise. You may have heard a power steering system. If the fluid gets lower, the pump is almost dying. Those pumps have a whine to them that you can notice. Sometimes AC compressors have when they lock up, you can hear, oh, that's AC compressor. However, let's pretend you've got a pulley. Maybe it's just an idler pulley. Maybe it's a water pump pulley. It doesn't matter. We've got a pulley making noise in it. There's 6 pulleys down here, bro, and I can't stick my head in there, so I'm not sure which one it is. What you can do, get creative, is my little example here. You can take the belt off and try to spin the pulleys by hand. Now, are you going to be able to spin the pulley by hand fast enough to make it make noise? Maybe. Maybe when you spin the pulley, you'll be able to feel that the bearing is gone. That happens sometimes if it's bad enough. But maybe you can't. So you can take your drill, and the chuck of the drill has a nice wide diameter. So nothing in the drill, but just the very end of the drill where you put bits into, and you tighten it so that the bits stay in the drill. It's called the chuck. It has a big wide diameter. So what you can do is take the belt, put it on whichever pulley you suspect, have your friend pull the belt nice and tight, loop it over your drill, turn the drill on because drills do very high speed. That will spin the belt, which will spin just the one pulley, and then you can see if it's the noise. If it's not, take the belt off, stick it on another pulley. There are lots of little ideas like that that you'll see watching the other techs, and that's my example. So with this, because there's no check engine light to prove it, there's no electrical failure, it just is making some noise, we're going to have to get kind of creative about how we find it. So we're back in the garage. I wonder if you guys actually like it when I do this little garage thing. But look, there's no Mazda in here. We got a new bike. This is our new project, XR250. I'm so happy to have my garage back. I'm sure you could tell. Got the keyboard out for the babies. So this guy bought this bike in '95 and it sat up for 20 years. And now he wants to get it running. So I'll be getting into that here shortly. I thought it would be interesting to show you guys. I have a couple crankshafts here. These are out of dirt bikes, so it's a very simple crankshaft with a connecting rod made onto it. But it works just like it would in a car. And this one will rotate. So check this out. If you struggle with the idea of how the piston moving up and down the connecting rod turns into rotational. I'm going to try to spin it here. Into rotational direction. Imagine there's a piston keeping that connecting rod centered because it would be in a cylinder going up and down, but that's the gist of how it goes up and down and rotates at the same time. Everybody rejoice. This is a very short lecture because it's supposed to be supplemented with a lot of hands-on, but so you're about halfway through. Ta-da! Let's review exhaust smoke. If it's blue, what does that mean? We're burning what? Engine oil. Engine oil burns blue. You remember the video we watched in engine performance? It's a slight blue. If it's burning white, what are we burning? Coolant. So it's probably actually steam. Water somehow is getting into the combustion chamber. If it's excessively black, normally exhaust is gray, but if it's excessively black, what is that? It means the engine's running too rich, or there's a catalytic converter problem. Normally the engine's running too rich. This doesn't happen as often now that everything's fuel injected, but if you see this, a vacuum leak would cause the engine to do what? Well, a vacuum leak would cause the check engine light to come on, obviously. We'd have a lean code, but it would make the engine do what? It would rev up, it would idle too high. You would notice that your idle is too high if you couldn't hear it, which you may not be able to. And obviously we're not going to be very efficient this way. The closed loop system is trying to decide how much air so we know how much fuel, and the whole time the O2 sensors are telling the computer, hey man, something's not right. I don't know how much fuel to spray, and I certainly don't want to run lean, because if I run lean, there's a chance the engine might explode. So let's richen it up a little bit, because we don't know what we're doing. Now I'm running too rich for no reason. Now I'm getting terrible gas mileage, and the engine idle's too high, and so vacuum leaks are not good. And who remembers my quick, cheap, easy way to find a vacuum leak? A can of something flammable. So brake parts cleaner now is no longer flammable. I found out the hard way the other day trying to kill some wasps. But carburetor cleaner, starting fluid, any of those cans of spray you keep on the shelf that will ignite, if you spray a little bit and it does get pulled into the intake system, so let's pretend you found the intake leak, then it would cause the engine to increase its RPM, or sometimes it will stumble. It'll kind of, oh man, did it just almost stall? Well, then you are close to the vacuum leak. Also, please remember, don't go crazy spraying this stuff. It is highly volatile, and so if you empty half a can into the intake, the engine will explode. So just a little sprit, little spray, pss, 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 like this, and then walk around the intake system until you find the leak. So this part here is kind of what we're really talking about today. So I got some pictures to try to help. We're getting ready to pull this engine out. So we've already decided that it needs to be overhauled or whatever. So we're prepping. And I cannot tell you how important it is that you do a little bit of prep. What fluids do we have to drain? Well, if we're going to disassemble the engine, the oil needs to be out of it so we don't make a mess. I'd like to get the coolant out of it so that I don't make a mess when I remove the engine. Do the power steering lines need to be disconnected? Does the transmission stay in the car, or is it coming with the engine? Does that need to be disconnected? I think that's all the fluids I can think of. So, and then also what's very important here is, did those lubricants or those fluids, did they get put on the ticket when I priced this out? When I told the advisor it was going to be 10 hours or whatever to pull this engine out and put it back together, did I remember to make sure I got fluids? And we might as well change the oil when we're done. Which, if you guys didn't know, if you ever pull a cylinder head off, so engine was overheating, it's got low compression, any reason we need to pull the cylinder head off, because there's coolant in the head, when you pull it off of the cylinder block, coolant is going to go all over the place. And some of it is going to land on top of the pistons, and the piston rings are going to allow the coolant to get by. So coolant will now be in the oil pan. 100% of the time, if you pull a head off, expect that you now have coolant in the oil pan. So it needs to be priced out from the beginning that when I get done with this, I am going to run a half a quart or a quart of some whatever garbage oil. We're not keeping it. You'll leave the drain plug open and just pour a quart of oil in it and let it run out and try to get anything that's in the oil pan out. And then we're gonna fill it back up and put a new filter on it. Do I need to recover the Freon and price out a desiccant? Ooh, that's time consuming. Maybe I don't want to. Maybe it would be easier if I unbolted the compressor from the engine and let it stay in the car when I remove the engine and or transmission. And so this is a vehicle by vehicle situation. Probably you're always going to want to be able to leave the compressor in the car. So the 4 or maybe 3 bolts that hold it to the block and the one connector, undo those and then use zip ties or a bungee or a coat hanger to hang the compressor. Don't let it dangle by its own lines, but try to tuck it away in a corner somewhere so it can stay and you didn't have to disconnect it. In some cases, the hard lines prevent you from being able to do that. So one of those things, please don't get rough with a line. But if you just don't feel comfortable, remember to price that out. That's an extra hour labor. And then we just went through HVAC, that if it's been disconnected for any period of time, we're going to need to replace the desiccant. So let's just see if we can spot the compressor. We did this a minute ago, so there's my compressor right on top. Hard lines, but look how much flexible rubber line we have. And I feel pretty confident that if I was going to pull this engine, given how much rubber we have there, that I could pull that compressor out and lay it to the side and leave it in the car without dropping the transmission lines with the engine and splitting it on the ground, or am I taking one or the other? And then this again is a vehicle by vehicle question. And so I say that only if it hadn't occurred to you. Sometimes it is easier to drop the engine and transmission as one or pull it out of the vehicle as one and then split them when they're on the floor or on a table. If you have a rolly table, you can roll it under the car and then drop it on the table, which is the best way to do it. So it was a Nissan Sentra that I needed to put a clutch in, and there was very little holding the engine in. 2 coolant hoses and a couple connectors, and it just made better sense to drop them both and split it on the ground, because trying to stab a transmission back into an engine can be rather difficult, especially inside the vehicle where you're working with the confines of the fenders and there's other guys in the way. The rack is in the way. Cody, I bet you're smiling right now. This last week, Cody helped me stab a transmission, and it whooped my behind for like 2 hours because the engine was too low, and then the engine was too high, and then I was hitting the fender, and then I was hitting the rack, and just putting them together would have been much easier on the floor. But with what we were doing, that wasn't a good option. But anyway, something to consider. And I have some pictures here. I wanted to kind of go a different direction and talk about this in a different way. So blow this guy up. There, get any bigger, stupid. There we go. So here is your front wheel drive setup. So the engine and then the transmission is mounted. And if I did this because I want you to see how long this is. So this is a very big assembly with engine and transmission together. In most cases, you're not going to want to try to pull these two out together, especially rear wheel drive vehicles. So this setup, the transmission would be up under the firewall, up under probably your feet. So trying to get it up and twist it so the transmission doesn't hit the firewall would be difficult. Do I want to take the whole front clip of the car off to make room? Maybe, maybe not. Whereas, I believe this picture here, this is an engine and transmission out of a front wheel drive vehicle, and it is much more compact if we look at it from the side. I can't make these both fit. So, a lot of times, if we're going to do apples to apples, this guy you probably don't want to take out together. This guy, though, you probably do. So, something to weigh. We've also got, how are you going to get this guy out? Well, you're going to use a cherry picker, right? Everybody's seen this guy in the shop. This is a very super helpful tool, but it is limited, and I say that for a reason. I'm going to show you on the next page. This guy is great if you are going to drop the car, drop the engine or transmission on the floor. You can hold it like this and then drop it down at the bottom. If you have enough room in the ceiling, you can take it out of the top. This is your better solution if you're not working on a lift. You guys that work at a dealer, have a lift, are probably going to want my next example here. Oh, nope, I'm sorry, I got ahead of myself. So this is what I'm talking about. Imagine trying to get this engine and transmission to slide in, don't hit the firewall, don't scuff up the front grill and the crash bar and all. Please don't scrape. He just painted this thing. So this can be difficult. You may not want to try to tackle it this way. And then here's the same situation in a Miata. You see how twisted they have it to try to get the transmission to slide under the firewall, hoping that this oil pan won't bend the radiator or the condenser or whatever we have going on in the front here. That, I mean, it can be done. We did it. I helped my neighbor do it in his 69 Camaro. I wish he'd have taken the front clip off, but he didn't. And it took us a good hour of wiggling it and trying not to scratch any paint. This guy is a better solution for almost anything because we can put this on the fenders of the car, suspend the engine or transmission, or just the engine if it were just taking the engine out of a rear wheel drive, and then still be able to move the lift up and down. So with that cherry picker, if you've got it use suspending the engine and you, oh man, I forgot to take some bolt out of the bottom, I sure wish I could use the lift to put that vehicle in the air. Well, you can't because the cherry picker's not coming off the ground. This guy goes on the fenders, so you can move it up and down like, oop, went to the wrong monitor, over here, like right here. So we've got the engine and transmission suspended, and if this was on your lift and you decided, oh man, I gotta get the subframe out of the bottom or something, you don't have to worry about it. You can move it up and down. So this is a very bulky piece of equipment that takes up a lot of garage, but I think this is the best way to do it. A lot of what we work on is front wheel drive, and so in this instance, it might be better to do the engine and transmission. But either way, if you wanted to just drop the transmission on the floor and roll it out of the bottom of the vehicle, that's how I did the clutch on this Mazda. Then this would have been I wish I had one of these. That's what I'm basically saying, guys. I wish I had one of those. And then say different piece of hardware, but same idea. They come in lots of different flavors. And our front wheel drive vehicles have this thing. This is the subframe. So because it's a unibody, it doesn't have its own chassis, and we need something rigid to mount the suspension to. So the transmission probably has a mount that bolts on this subframe and holds the transmission. The engine probably has at least one, and then of course the rack gets bolted to it, and then a lot of the suspension. In order to get an engine and transmission out of the bottom, this guy has to come out. And what I have seen, which is pretty cool, I have seen guys, instead of trying to take the subframe out first, just drop the whole thing. So in this situation, he undid the struts from the strut tower, took the subframe bolts out, and then just dropped it on him. So when we had rolly tables at work, we would do this. We would roll a table up under the car, lower the car so that that A-frame was holding the engine and transmission. Unbolt the subframe, it would come down an inch to the table, and then we could lift the car all the way back up and then roll our table out and then be able to work on the vehicle waist high, which is a pretty cool way to go about doing that. So things to consider, we're coming out of the top or coming out of the bottom. Remove the harness or leave it. So some engines run the big loom, the big wiring harness under an intake manifold, or Toyota loves to do that. The plastic intake manifold covers most of the harness. And do I want to disconnect every connector off of this engine or leave it? Well, I didn't know leave it was an option. Oh, well, I'm here to tell you. Sometimes, and a lot of the quality manufacturers will have a big connector somewhere in the engine bay so that the entire engine harness meets this one connector. So my experience at Toyota was if we're pulling this engine out, and what we'll do is we'll leave all the connectors connected to everything on the engine. Undo the one big connector from the rest of the harness, pull the engine out, and as I disassemble the engine on an engine stand or on a table, then I'll slowly undo each connector and not have to fight with the loom while I'm bent over the fender or up under the car. So, depending on what you're working on, that may be a better option. So, keep that in mind. How much to send to the machine shop? So, the head is going to the machine shop. A flywheel is going to the machine shop. Any wearable item that we're going to want to reuse, why don't we machine it ourselves? Well, why don't you paint it yourself? Plenty of reasons. You don't have the equipment, we don't have the know how. There's $1 million worth of equipment in the machine shop that we just don't have, and that's a specialty niche. That's like being a paint body man. It's automotive, but that's a different career path. And if that's what you're into, chase it. I love it. Every time I drop something off of the machine shop, I linger. I'm like, I want to see what's going on in the back. And they go, go on, get out of here. No, I just want to hang out for a minute. Let me see. How do you guys do that back there? Go on, get out of here. You're not allowed in the shop. I know, but I want to see. So one thing to keep in mind that when you send something to the machine shop, take everything off of it. Don't leave a coolant temperature sensor in the side of the head because they are going to sandblast it, paint it, deck it, whatever they're going to do to it. They're going to have to remove it. And I am telling you right now, if they have to remove it, they're not going to put it back. And then later you go, hey man, I sent it with a coolant temp sensor. And then this machine shop is going to tell you, well, you shouldn't have. We don't have it anymore. It must have got thrown in the garbage. So this is just, I know that sounds harsh, you guys. Oh man, machine shop sounds like they're assholes. They're not. They're just, this is the way we do things. If you send something to a machine shop, take everything off of it. Don't send it with anything they don't need. If the valves have buckets or rockers, label them so in case they come off, they know where they go. So take a Sharpie and write 1, 2, 3, 4. Or I've seen guys take a piece of cardboard and then stab parts, like maybe valves, through the cardboard and then label them 1, 2, 3, 4 with the front of the engine going this way so that when it gets to the machine shop, it's easy. They don't have to call you. The longer it stays at the machine shop because they have questions, the longer it will be before you get it back, the less you're going to remember about how it went together. So, just one thing, um, just be good to your machine shop and they'll take care of you if that makes sense. Will it need an oil change? I kind of got on that earlier. Yes, it's going to need an oil change 100% of the time. If you've done any kind of engine repair, major like this, go ahead and expect. What about just the intake manifold? You know there's coolant that goes through the intake manifold, and if it's a V engine, so it's your V8, and all that coolant goes down in the valley, it's going to end up in the oil pan too. So you know they need an oil change anyway. How much does it cost? Just they're spending $2,000 on having the engine rebuilt or having a head sent off or whatever. They can afford an oil change. Another thing that I want to touch on here is if we're removing an engine and transmission, the transmission is going to have axles, and the axles are going to have to come out. So, are we going to lose some of this transmission fluid? That's something to consider as well. What will make this job easier? 100% this is worth your time is if it's the first time. So let's pretend you work at Toyota and you got a new RAV4 and you've never taken this engine out and you've made friends with at least one other person at this dealership because you're not a complete dummy. You might go over there and say, "Hey, Bill, have you ever taken this engine out of this car before?" And he'll say, "I haven't, but Tom has." And you go, "Hey, Tom, I heard you pulled the whatever 2AR out of a 19 Rev. Is there anything that you would do different, or anything you would just tell me real quick? I don't want to take up a lot of your time." And he might tell you, "Don't try taking it out of the bottom; it's not worth it. Take it out the top." Or he might say, "Take the engine and transmission; it's so much faster." Or if I could do it again, or next time I do it, I'm gonna do this, and then um, take that and absolutely run with it because there's nothing more valuable. You're not gonna find any of that information in the repair manual, so I find it's just one of those things. Sometimes it's good to have a buddy at work. So we're trying to decide, are we taking this out of the top or the bottom? So things I'm looking at are how far back does the engine actually go? And I know it's dark outside, you guys can't see very well, but I'm looking at how deep under the cowl where the windshield wipers does this engine actually go. So in this one, the cowl will come out, and I'm going to stick my hand. This is where the end of the engine is. So with that cowl removed, there's plenty of room back there. Let's look up front. There seems to be plenty of room here. I might try to take that engine out of the top. So let's go over here on Wife's Highlander, front wheel drive V6. Look how deep under the cowl that engine goes. It goes a good ways. I can take the cowl off, but what worries me really is the space in between the front of the engine here and the fender. There's maybe an inch. And I'm not gonna lie, if I had to pull the engine or transmission out of this vehicle, I think I'm going out of the bottom just because I don't trust it. Alright, we're gonna recap real quick. Good news, you're almost out of here. We're almost done. I found a little animation of the four strokes happening, so I'm gonna hit play, and we're gonna go through this together. And this crankshaft looks like the one in my garage. So intake, compression, power, exhaust. Intake on the left. Man, that's just how I drew it. Imagine that. Intake, stroke. Yeah, we know. Come on, keep going. Compression. Oh wait, we have power. Ooh, that was off. Oh, this animation's throwing me off, guys. There was my power, and exhaust out that way. So what's not shown here is the camshaft, and keep in mind the crankshaft makes two full, so that was one revolution, two full revolutions for one four-stroke cycle, whereas the camshaft on top that's actually opening these valves would have only rotated once. And this is super important for engine mechanical, is the RPM of the noise, the knock. So if it's valves tapping, that's going to be half as fast as the engine RPM on the bottom because the crankshaft spins, like I said, twice as often, twice as fast. So that may clue you in on there's a big difference between 500 RPM and 1000 RPM. And exhausto. Alright, that's enough of that one. And then check this out. I found this website. I just Googled how engines work, but it says animagraphs, how an engine works. So check out this. This is pretty cool. This is a good animation here of the four strokes. Again, if you are concerned about how that connecting rod wiggles like this, wiggle, 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 and it makes my crankshaft go around, so that's pretty cool. Fuel injector here, direct port, very nice, so it sprays right before the intake valves. Another thing too, imagine this is the intake manifold. If you were struggling with why this circular valve moves and allows air in when it opens, maybe this will help you. And I think this is cool too. So from the side, we've got a four-cylinder, and you see that we're not all on a power stroke together because that wouldn't make good sense, right? So the firing order might be something like, let's see, we'll do you, and then two, and then probably four, because four and one are doing the same thing. So it'd be like 1, 3, 4, 2, 1, 3, 4, 2. So that's pretty cool. Now, you can see if you watch how quickly the cams are spinning
versus the crankshaft. These two cams are spinning much slower. The RPM is much slower. And I think it's worth noting that the pulleys, this is always true, and I'd take you out in the shop and show you. The pulleys or the sprockets on these cams are normally twice as big as the sprocket on the crankshaft. It's like there's a reason for that. Gear ratios or something. So that's all pretty cool. Your basic configurations, your V-twin motorcycle, your flat four, that's what my Subaru is. V6, V8, we know all that stuff. Here are your fuel injectors. So again, I think this is cool. And you rarely get to see proper information. I like that this website right here says using higher octane fuel does not actually do anything but waste money. Like it says that right there. Thank you. Preach it. Going to church. And then my intake system, we know all that. Oil, this is really cool. So I told you we got to get oil up on top to the camshafts. So there's probably more than one circuit. There's probably at least two in most engines, but this is a nice simple illustration of, and oil goes through the crankshaft to get onto all those bearings. So crankshafts have holes in them, camshafts do too, which is pretty cool. My cooling system, we absolutely should know cooling system by now. And what else is on here? Oh, we got some ignition, that's cool. We probably don't have any distributors anymore. Now it's all coil over ignition, a coil directly on top of the spark plug. So we would redo this and we would put a powertrain control module here and some coils on top of each one. But again, I think it's pretty groovy. Cool little website and your exhaust. Lehat and everything working together. So check that out. That's pretty cool. All right. I think that's it this week, guys. Again, I told you to get attendance. I need you to do that forum. Next week, this lecture will be much longer than the next 2 weeks because there's a lot of parts and I want to show you each part and best practices and all that. So make sure you check that out, and then I'm going to probably pull some tools out of my toolbox next week to show you guys some, basic engine repair tools. But either way, get your CDX started, and I'm looking to see. I'm going to check the CDX. I'm going to check right here on this forum, and I'm expecting to see replies from all of you by when I check it on Thursday. If you need me, call me, text me, and I'll talk to you guys later.